Let's see if it likes that better. Okay. Print reversing sign of pitch velocity. Pitch acceleration is a constant. Oh, I see what's happening. I think I see what's happening. Reversing sign of pitch velocity. Before applying acceleration. Pitch acceleration we don't have to print out, but I will just for print pitch acceleration. Shouldn't it be the acceleration that you reverse? No, the bounce is to reverse the velocity. Otherwise it would like be a balloon, or worse than a balloon. Pitch acceleration. Pitch velocity after applying acceleration. Okay, let's run it. I think that's enough. Okay, what went wrong? Pitch acceleration is always minus 300. Pitch after calculation. Pitch velocity before applying acceleration. Why isn't it reversing the sign of... There it reversed the sign of pitch velocity. So pitch before calculation is 23. Pitch velocity before applying acceleration is minus 30. Pitch acceleration is minus 300. Pitch velocity after applying acceleration is minus 45. Reversing sign of pitch velocity. Pitch after calculation Let me read what the person said about it. Here's what's happening at the end. The if statement that flips the sign of velocity will still flip the sign even if the velocity is positive. That means the ball doesn't have enough speed to get over 25 in one step. It will still sink downwards. It should be a bit easier to hear what's going on in a slower time step, and maybe you could flip the pitch so the pitch increases as the ball gets lower. Let me see if I can explain that with the numbers that I have here. For one thing, I want to print just a line. Pitch before calculation, pitch, play note. One takeaway, pitch acceleration, pitch velocity after applying acceleration. After reversing sign of pitch velocity. I don't need to change the, I don't need the pitch after calculation. Well, I'll put it in there. All right, let's try this. Wait. So the reversing side of pitch velocity, I must have put something wrong here. Okay, let's see about this. It's still at minus 60. That doesn't make sense to me. Oh, because I put it in the wrong place. Yeah, okay. There we go. Pitch for calculation is down to 26. After the calculation, it's up to 27. It's at 23 with a pitch velocity of 45. Oh. The ball didn't the ball was at 20, the ball fell to 23. You know what, what's the library that's for plotting with pi? Matplotlib. Matplotlib. I don't want Geeks for Geeks, or I definitely don't want W3 Schools. Matplotlib.org, that's a little better. Let's do try all of this. Except keyboard interrupt break. Then I guess I have to write this inside of there. That would make more sense, wouldn't it? Try except break, then let's just say pitch history equals empty list actually equals pitch. Oops. Pitch history equals pitch, and then at the end of this, print pitch history dot append pitch. Then plot pitch history pitch history show. Let's see if that works. That should be fine. Pip install matplotlib. That's a big library. Okay, now we do main.py. Interesting how if I do Control C again, then it'll. Wonder if I'll lose my plot though. Okay, so now we're gonna get a. Can I actually do this inside of the thing? Can I show it like every time? Oh, but it's gonna be on the wrong. Oh, it interrupts. Okay, no, that doesn't make any sense to do it that way. We'll just have to be patient. Oh no, this is annoying. Another keyboard interrupt, and that should get me out of it. Oh no. We're just gonna kill this terminal, and then I'll get rid of it. Control tick. Source. CD musical physics. Python main.py. Okay, that's that. So this gives us a picture of what was happening, which is kind of neat. Let me take a screenshot of that. So now it's, but why does it go for lower? Why does it drop lower every time than, that's mysterious. 73, x is 74, x is 75, x is 76, 19.86, 17.70, 19.02. Let's look at that alongside the actually let's have pitch velocity history equals pitch velocity, and let's then look at pitch velocity history dot append pitch velocity. Now the question is, do I need to rescale this? Because pitch velocity, pitch itself is like 20, well, 0 up to 50, but pitch velocity, oh, it's like similar numbers. Okay. PLT.plot pitch velocity history. Close this one now. So it so velocity starts at 0, and then it gets down to minus 104, jumps up, just gets to like minus 104, jumps up to 118. I don't understand why it ends up higher than there. Each time the velocity is a little bit less, and then it levels out being at, I'm going to say like 45 and 30. Minus 30, 45. How is the velocity higher on the up and lower on the down, but the thing is still losing altitude? That's mysterious. Again, the reason this is not happening like normal physics is numerical approximations. Let's say pitch velocity history equals, we're just going to x for x in pitch velocity history will be x divided by, I want it to like 1/10 as big. So this is the height, and this is the velocity. Oh. Maybe it's like that. Wait a second. This is at x of 63, 64, 65, y at 4.2, y at minus 3. Well, let's make another. Let's do another approach to this. How do we do Python async? Async IO is a library to write concurrent code using the async await syntax. Okay, I think all I have to do is say we do a population frequency equals 0.001 and playback counter equals 0, playback ratio equals, let's see, I've cut this in by 10 and by 5, so 50. Now def async def async def play note asyncio.run play. What did I call that function? Play piano. No, it's called play piano note. Well, I guess I have to define it first. Usually, sometimes you don't have to define functions before using them in Python. All right, let's see if this makes sense. Oops. No, I didn't do that right. Print running me. and times calculation frequency times calculation frequency. Hmm. Oh, you have to call the function there. Okay. I'm still not doing it. Oh, that's because I commented out that thing. Now let's try it. Okay, we need a much stronger value of acceleration now. Add like 300 times 50. So then it should feel the same. We'll do 300 times 100. That was just too slow. Yeah, it's still too slow. Let's make it 5 times faster. Although this at least is working. Let's see, I want to make this so that it... I'll deal with that later. Let's get it sounding right first. Oh, it's still losing height. That's interesting. It's not as egregious, but it's still happening. Let's make it way faster acceleration and see if it has the same problem. Yeah, it immediately has the same problem. How come increasing the calculation frequency didn't take away that artifact? I thought if I just ran the calculation more. Well, there's an alternate way to approach this. Um, we can just, let's use NumPy. As NP. Let's do time np.linspace array like float co. So let's do 0 to 20 seconds. Num equals 10 times 44 100. Oh, let's make that 20 seconds. And do I really need to do it at audio frequencies? I don't think so. Let's just make it 20,000. And let's think about the math of this. Um, if acceleration is constant and negative, oh, but this is actually kind of tricky because it's easy to write a parabola. That's just minus x, like something minus x squared, 1 minus x, or 80 minus x squared as x goes through those numbers. But then how do you know when to switch to, as soon as you add the constraint? Okay, I don't want to take this approach. Change my mind. I want to think about let's just add another. I think that it has to do with calculation frequency. Let's actually divide that by 100, by the way. The calculation frequency needs to be short. There need to be a lot of calculations per each oscillation. Let's try it like this and see how badly it does. I want to see how high it goes up again, even though this is going to take a while. It speeds up as it falls down. I start? I started at 50, so how close to 50 is it going to get? I got to 7255. So even there, it kind of struggles. If I do this another, gosh, but I don't really want to wait for that calculation to happen. So let's copy paste. We'll do main 2.py. This is interesting. I can take away this running me thing. Let's think about, we do it as an equation, 50 minus t squared until reaching a certain point. Maybe I can just do use math.py. Sort numpy np len space 0 to 20 by 10,000. We don't need that many. 0 to 20 by 2,000. This should be plenty. Now I think I can write x equals t equals this. X equals t. I don't know if I can do this though. Modulo 4 minus, so t goes from 0 to 4. T modulo 4 minus 2. 50 minus t modulo 4 minus 2. And then let's do the pyplot thing. plt.plot x plt.show. Let's see if this one ends up making any sense. Python use math.py. So there's our velocity. We can use that to calculate our position. Right? Or, so that's t for time, that's velocity equals that. Velocity is equals that. For velocity in velocities, let's do positions equals start position is going to be also 50 for some reason. Positions dot append positions -1 plus velocity. Let's plot plt.plot positions, plt.plot velocities. No, that's all wrong. Okay, let's take away positions for now and just run velocities. Oh, that's why it's a problem. Oh, and this should be squared. That's why, that's the part that I forgot. And we need to, okay, let's see how this looks. There. Let's just adjust the numbers slightly. How do I get it to start at? Oh, we can just start this at 2, and we'll do this minus, oh, we still have that plotter open. It's going to -3. So let's just add 4, call it 5. And if we take all of that times 10, surprised it lets me get away with that. Now we've got 50 dropping down to 10. Let's up that by like 20. This is so hacky, but it's okay. Let's say that we want 8 of these per second, and we want 20 minus 2. 20 minus 2 times 8 is how many of them we have. Let's plot velocities again. Look at how the bottom node is like, now it's kind of inconsistent how low it goes. That's another numerical error going on, but I don't care as much about that one because that doesn't make it lose height over time as badly. So 20 seconds. Let's make this go for 40 seconds. 40 minus 2. Oh, let's take it from 22 to 42. Then we just want to note for now we need to set up the piano. Whoa. Oh, this is positions. Right. Velocities doesn't exist anymore. Let's do it again with... Oh my gosh, that didn't sound good. What was that? How many long is this going to take? 42 seconds. Oh, point 125. Let's quit that. Forty-two seconds is a bit long. I'm gonna drop this down to 22. But I'm gonna let it finish. There we go. And it makes that pretty thing. Let's even let's do 2 to 14. 14 minus 2 to 8. Okay, that's more reasonable. It drops 1, 2, 3 times and then comes back up. 1, 2, 3 sessions because I went from 2 to 14. Now what I want to do is let's choose a diminished scale scale equals, so pattern scale pattern is whole step, half step, whole step. Actually, it'd be kind of fun to use a whole tone scale, just all whole tones. So I just want Python round to even number. Oh, there's just divide the value by 2, round to the nearest integer, then multiply by 2 again. There we go, that works. Import math. So scale pitch is 70 an even number? Yes, it is. Scale pitch equals pitch divided by 2 round of u, round of pitch divided by 2. It's 2. Sure, that'll work. Now let's see how that sounds. I like that. Now let's scale pitches equals empty list. Scale pitches dot append scale pitch. Plot scale pitches. Plot.show. Okay. Yeah, cool. Now we see the, oh, interesting. It still is kind of inconsistent on how it does that. And you know what? What else we can do? We can do a couple of things. We can do plt.plot. What's this called? Oh, that's let's call it pitches. That's a cool graphic. That's going to be the thumbnail for this. Well, it's do it like this, so it's the right aspect ratio and stuff. Let's clean this up. I guess I don't need math because round is just a built-in thing in Python. Duration equals 12. Period equals 4. Length of piece in seconds. Length of drop. Time for one cycle of drop and bounce up in seconds. This way we don't have a bunch of magic numbers floating around. We go 2 to duration plus 2. And here it's duration minus 2. Or just duration itself times 8. Note frequency equals 8. Number of notes played per second. Scale equals whole tone. Scale to follow can be none whole tone to do add other scales. I call that time. Pitches equals, and now let's see here. I want there to be a highest starting point, starting equals 80. Lowest floor height equals, we'll do 25. Now this is kind of going to be tricky for me to figure out, but I think I can do it. Take away the plus 20 here. Starting height minus time modulo 4 minus 2. Let's put another parenthesis in here to make this more clear. Let's do let's do a if name equals pi. So I can if name equals pi, what am I saying? Main let's def main all these things go in here. Time is that, pitches, here we go. Apply scale of pitch scale if scale is none, pitch elif scale equals whole tone, return else phrase not implemented. Okay, scale is whole tone. Apply pitch of pitch Let's scale. I'm going to print. I'm going to leave out the printing. I need a better, so time modulo 4 minus 2 ranges from -2 to 2. 12 is just a total guess, so it's probably wrong, but let's try it. Let's just make sure this works. Something like what I wanted to. Nope, it's not working at all. What did I do wrong? Oh, did I turn my volume down? So we've got our notes. What did I do wrong? Got apply scale. Okay, let's print these things. Make sure that's happening. Oh, it's way too high. Ha! Okay, I need to rethink this for sure. Definitely not times 12 here. It's in ranges that I could have the numbers, but it's still not making any sounds. Oh, this got to be starting height minus floor. This might be a job for ChatGPT, honestly. Or to do it on paper. Let's see if we have. And by paper, I mean typing things. Wish I had versioning on so I could see what the previous version of this equation was. Although I really want to know why my piano is not making any sound. There it goes. And there's your graph. Floor height is going to be the ratio that comes in here somehow. That's what it's going to be. So the maximum here is modulo 4 minus 2, so +2 to -2. Wait, time modulo 4 squared. So it's always going to be okay, how far off is it if I just do it this way? Okay, I think I see how to do this now. We need the ratio of starting height, so times, what if I do starting height divided by floor height? Uh-oh. There's something wrong there. The heck? Pitches equals starting height times that. Yeah, definitely. That's not right at all. But how about floor height divided by starting height? That's still not right. We have time ranges. We have x squared times foo equals 25 when x equals let's see if that's better for helping me think through this. Oops, I didn't want to print them. I wanted to plot them. Oh no, it's one then the other way? That's annoying. Time, comma, pitches. Time, comma, scale pitches. Let's reduce the duration to 4 for now. So I want it to only go down to 20. What happens when I... I just use magic numbers here. Okay, let's go back to duration of 12. And just give it a listen. What if I do 0.66? What's that going to give it to at its minimum? It's down to 18. Oh, I want it to be less than that. What if we do 0.5? I took it down to like 30 something. This is close enough. What if I say I want it to only go down to 40? Yeah, oh, note frequency is not being used? That's weird. Oh, times note frequency, okay. Oh no. How about 1 minus floor height divided by starting height? That's still not there. I need a factor here so that oh, this is wild. It depends on the period. I could take an iterative approach to just correct the range, but that's annoying. I don't want to do that. Because like the period could be 5. And let's do 15, which would be the length of the piece. Well, that was weird. Oh yeah, because it's a period of 5, it's going to be different. Let's fix that. Duration plus period over 2. And then this is going to be period divided by 2. So this is going to have a value of time goes from period over 2 to duration plus period over 2. So it starts at period over 2 modulo period, that doesn't matter. So it starts at 0, but it goes up to time keeps on ticking, but time modulo period gets as far as period. So period over 2 squared is the maximum of this is period over 2 squared. So if I go outside of this, and divide the whole thing divided by period over 2 squared, and take out this multiplier, where does that take us? Let's take away the starting height multiplier for now. That's not helping. How about this whole thing divided by, what branch does that give me? Yes, that gives me a thing that's going from 0 to 1. That's helpful. So now I just map 0 to 1 onto now it's going to go from we need floor height. Starting height. Starting height minus floor. I think this might have it. Got it. We got him. You know, we can easily implement none, whole tone, none, comma, whole tone, comma, or chromatic. Let's pretend that we just put chromatic in here and it should raise a not implemented error. Type error exceptions must derive from base exception. That's confusing. Well, anyway, let's do L if scale equals chromatic turn round of pitch. Simple as that. I like it. Oh, my noise filter thinks it's noise though. That's weird. Let's turn off the noise filter. Now you'll have some background noise, but you'll be able to hear the music a lot better. I think that's a win overall. Let's add a diminished scale. Actually, let's do none. Try it that way again. Okay. That works. We can just delete main 2. I don't think I did much with it. I'm going to refactor this to import scamp because I don't know what scamp is importing. Scamp.session. Piano class. Is that the only place that we're using scamp? Yeah, that is. Let's make sure this works. What if I run like multiple of these at a time? Source.venv can activate. Oh wait, what? Oh, yeah, duh. CD musical physics Python use math.py Python use math.py. So what if we do def main pass one ball time dot sleep. We need to import time. Time dot sleep. 2.5 one ball. Python multiple balls.py. Oh wait, it's not gonna, that's not gonna work. I need to use async. Import async IO. Async IO.run u and async IO.run u, and we need u to be a async def one ball. Now let's try that. What? I probably need to take out the plt.show stuff. But now it doesn't play anything. not. This needs a little more thinking, doesn't it? Why isn't it doing it asynchronously? Let's make the duration a lot slower so that when it fails hilariously, it doesn't take me as much time. Whoa, this function cannot be called when another async event loop is running in the same thread. Clearly I'm doing this wrong. Python async tutorial. Maybe if I do async io.gather, time.sleep wait time. What if I just do one ball of 0, one ball of 1? Maybe I don't need the... Let's try that. Because I gave it a tuple of things. Well, now it kind of did something. Okay, it's time to pull out ChatGPT. New chat. Might as well probably need to refresh it anyway. I want to write a Python program that uses asynchronous processes to have a main function that calls one function, one other function, write a Python program, write a Python program that, hello Sammy, good kitty. Asynchronously calls a function, waits 1 second, then asynchronously calls the same function. Oh, that's interesting. Sammy, go away. I'm busy. So let's just copy all of this. Import async.io, we've got async def my function. Await, I don't want to await my function. That's not what I want. With one ball, wait time equals 0 by default. I don't want to do that. This is just going to run the whole function, I think. There's nothing async about this. This is my asyncio.run main. I don't think this will prompt if there's anything. Oh, wait. Oh man, I have a bad variable name. Time var. Yeah, ChatGPT didn't quite get that right for me. Here we go. Yes. Okay, so now I just need to say one ball. Ball of 1 and comma 1 ball of 2. Okay, maybe if we do this as a, oops, as a list, just kind of spitballing here. Oh no. Okay, back up. Maybe that's what maybe that's what it's getting at. Okay, there we go. So now we can say one ball and one ball with 0.7. Well, a number of things went wrong there. I don't think it's working. What if I refactor it so we have s equals scamp.session 4 comma s, I'm going to do s comma 5 and s comma 4. Try this. No, it still insists on completing one before starting the other. Oh. Wow. ChatGPT. It worked! It actually worked. Okay, duration is going to be 6. Oh. No, there must be something else in here. This happens asynchronously, but there must be something in here that halts the other ones. It must just not be set up to do this. Darn. Let's watch more carefully what it did. What if we pull piano out? What's half of 0.125? 5.0625. Then let's enjoy this while we've got it working. Uh-oh, sometimes it doesn't make sound. let's put all these in here. Piano, wait time, duration equals 6. Comment out duration here. Period equals 2. Comment out period here. Note frequency equals 8. Oh, I've got to fix that up. Scale equals whole tone. Starting height equals 80. Floor height equals 40. One divided by, what did I call that thing? Oh, frequency. Note frequency divided 2. Now, one ball, piano, 0, random.rand int, import random, oops, import random, from 10 to 20, and this is actually going to be random.rand int from 0 to 4. Maybe I don't want it to be an int necessarily. Maybe I do. It's okay. Can I do random.rand range? Yes, I can. What's next? Period. From random.uniform, okay. That's better. Now what's this one? From 1 to 3. Six to 10. Next we have random.choice of none, whole tone, chromatic. Starting height equals random.uniform from 60 to 100. And is that the last one? I think we're on to floor height. Floor height equals, let's make them all be at 40. Oh no, I didn't save it at all before I grew into this random stuff. That's annoying. Oh well. For the range of 5. Let's see if that works. Oh, this is going to be a problem. Let's go back to when it was working. This has to be 1 divided by 2 times note frequency. Okay, cool. Now, multiple balls random. So for starters, let's track down where the problem is. How does it have more than even one thing here? Why do they sound so similar? Because I'm not using okay, it's not a problem with the for blank and whatever. It's something async.create task one ball of piano random.uniform 0 to 4, comma random.rand int 0 to 10, random.uniform 1 to 3, random.uniform 10, random.choice non-whole tone chromatic. Okay, there's my problem. What the heck? I don't want to edit the NumPy code, that's for sure. Don't save. Gosh. Okay, so for NumPy linspace, we need to we're going to change these to ints. Even though I'm not sure which exactly of these need to be changed and which ones don't. Hmm. There's obviously problems with it, but I think it's interesting enough to ship as it is. What did main do? Main 2 we can delete. Oh, it's not making sound anymore. This is probably a good time to end the stream. I feel like I've gotten a lot done. I'll have some lessons from this and some interesting things to pull out of it. Okay, cool. Good night, YouTube.